Today's goal is to find slope of linear functions, and we're going to do this in graphs. The slope of a linear function is the rate of change between the dependent variable y and the independent variable x. Okay, so today what we're going to try to find is how much is the line changing, and the way we're going to do that is by finding the rate of change in y and the change in x. It's important to note that when we talk about slope, slope is abbreviated as m, the letter m. Think about mountains have slopes, so a good letter to remind myself is m. M is for mountains, mountains have slope, slope is abbreviated m. It's also expressed as the ratio or a fraction. Okay? What is that fraction? Here it is. The slope is the change in y over the change in x. And a lot of times students think of this as how much the line is rising over how much it's running. This will make more sense after example 1. Okay. And important to note in our fraction over here, this is not a triangle, but it actually is a Greek letter called delta, and delta means change. So when I read this fraction, I read it as slope is the change in y over the change in x. So in example 1, we are going to determine the slope of this graph. How are we going to do that? We're going to pick 2 good points on the graph, then we'll find the change in y, find the change in x, and then write slope as a fraction of these 2 things. So looking at example 1, I want to determine the slope or the rate of change of this graph. And my first step is to pick 2 good points, and by good, we mean where the line hits the corners of the graph. So there's actually a lot of good points on this graph. We have one here, another one here, a third here, and even a 4th here. Now it's important to know that you don't have to pick a certain 2. You can pick any 2 good points. Okay. So we're going to focus on these 2 points. Focus on this one that I'm changing in red, and we'll pick this one. Again, it doesn't matter which 2 I choose, we'll always get the same answer. But I want to find the slope between these 2 points, or I want to find the slope of this graph. So we pick 2 good points. Let's find the change in y. The change in y is asking how much is the graph changing up and down, or how much is it rising. The way we're going to do this, the change in y is red, so I'll say this is the change in y. It's going up 1, up 2, 3, 4, 5, 6. So in this graph, from point to point, this graph is changing by 6 units. That's our change in y. Because it's going up, it's rising 6 units. So we found the change in y. Now let's find the change in x. To find the change in x, I ask myself, how much is the graph running or moving side to side? So we know it went up 6, and now the graph is also going over 1 unit, over 2 units. Over 1, over 2 units. Okay, so the change in x is 2. Change in y, 6. We've now found the change in x. Lastly, I just need to write my slope as a fraction. So here we go. Slope equals, again, the change in y over the change in x. For this example 1, we said the change in y was 6. The change in x was 2. So the rate of change, or the slope of this graph, is 6 over 2. Now, always a good suggestion, I should ask, can I simplify this fraction? And the answer is yes. 6 and 2 both are multiples of, or factors of 2. So dividing each numerator and denominator by 2, we end up with slope of this graph is 3 over 1, or another way we can see that is as 3. This is the slope of example 1, our final answer. We should be comfortable with both of these notations. The slope of our linear relationship is constant, meaning it's the same everywhere. So I can see this 3 over 1 in a lot of places. If I go back to my graph, here's where this idea of constant. Up 3 over 1. Up 3 over 1. Up 3 over 1. Kind of like staircases. I can always see this constant ratio happening. Up 3 over 1, 3 over 1, 3 over 1. So that means it's the same everywhere. And this does not mean, using the word constant does not mean that the line is flat. In fact, if we just look at example 1, we notice this is not a flat line, moving upwards. Important to note, so when lines are increasing or moving up, when lines are increasing, our slope is positive. Looking at example 2, looking at example 2, again we're asked the same question, determine the slope of this graph. So now I'm going to pick 2 more points. Here's one point, here's another good point. Again, any points in red would also be good here. But we're going to choose to find the slope using these 2 coordinates, or points. So again, I'm looking from left to right. I want to find the rate of change from point to point. So I notice this time the line's going down. 1 unit, 2 units, 3, 4 units, down 4 units, down 4 units. So my change in y in this graph, slope is the change in y over the change in x. Y is changing by -4. So the change in y is -4. My change in x, well, let's calculate that. We stopped here. We move over 1 space, 2 spaces in a positive direction from left to right. So that's 2 spaces. Positive. -4 over 2 can also be simplified. Both factors of 2. So this can be simplified into the fraction -2 over 1, or just -2. And this is our slope of this graph. This is our rate of change. Well, that means you can go down 2 over 1, down 2 over 1, down 2 over 1. Constant rate of change. Okay. So you can try example 3 and then figure out after example 3 what type of lines are positive, negative, and then the one that we didn't talk about, slopes of 0 will be flat lines. So I encourage you to try example 3, determine the slope of the graph, and then fill in the notes.